Okay, good morning everyone. My name is Sylvain Massip, and I'm the CEO and co-founder of OPSCIDIA. And I'm going to tell you today how we use generative AI to make the most of scientific literature. So, just a few words about OPSCIDIA to start with. We're a startup created with the aim of bringing the right information, the right scientific information to the right people. And of course, to do that, we use large language models, and we apply large language models to analyze automatically scientific documents, such as scientific articles and patents. We've built a customizable SaaS platform. The aim is that it fits and it can be customized to most of the use cases that people have with extracting data and value from scientific papers. We have already something like 40 clients. We are 9 people, and we have a strong research and development team with 4 PhDs, and we have a few nice clients. Okay. So what I'm going to tell you about today is how we do to use LLMs to extract scientific information from research papers. Obviously, it's very tempting to use technology as powerful as large language models for scientific information, because the volume of information is huge, and that's really where AI is good, is at treating a lot of data. But the problem is that intrinsically, LLMs are bad with scientific information. You all know about the limitations of LLMs, the fact that the information has no source, we don't know where it comes from, the fact that it's not always reliable, it's not always accurate, the famous hallucinations, and you've heard also about the problems of data leakage with the LLMs, and a last issue is that often when you ask a very precise questions to a LLM, the LLM answers with something less precise, doesn't really answer the questions. And all of these limitations, which are well known, are particularly problematic when dealing with scientific information, with scientific data, because in science we need to know where the information comes from, and of course we need it to be accurate. So that's the problem we face at OPSCIDIA, and I'm going to tell you how we make the most of the great abilities of LLMs and to circumvent these limitations. So we've built a scientific information platform where the user can ask a question with something as close as possible to natural language. Then we have an interplay between AIs, different AI pipelines, and a data set of 200 million pre-processed documents, scientific articles and patents. And really the aim is that this interplay allows to get the right information from the data set, select it, collect it, and gives it back to the user in the format that they need. It's very important to be able to adapt the answer to what you need. One very big thing, maybe one of the most important idea that we use to develop this tool is the fact that we need to organize a dialogue between our users and the AI. Our users are experts. They know very well their field, they know very well their job. They have an intuition, an experience that there is no chance that AI can mimic. On the other hand, as I told, AI is able to deal with vast amount of data, and AI is able to write clear, concise text that are grammatically correct, and it can do it very fast, whereas for us human it takes quite a lot of time. So really the aim is to combine the advantages of the human and the AI so that the user gets an answer that fits their need and that they have ownership on what they did with the platform. And so really, the big motto that I repeat very often to my team is that we have to build a system where AI suggests and the user chooses. So let's say that you want to write a report on a specific technology you're working on. How do we deal with such an issue from the user? Well, the first thing is that we have split the process of creating a technological report in 3 steps. First, there is the bibliography step. You need to have the right data into your report. Second, there is the outline step. When you want to create a report, you have to decide what's the outline. And then there is the just writing step. But the writing only comes at the end. And so we have these 3 steps, and for each step, we want the AI to suggest and the user to improve, validate, and make sure that it is correct and also that it fits their need. So then we do it step by step. First, the user gives his question, their query, and we interpret this query with AI. And then we look for a very wide amount of scientific information related to their query. So we are sure that information, if it exists, will be in our dataset. Then we collect the dataset and gives it back to the user by representing it among 3 dimensions. How relevant is the document compared to your query, when the document was created, and how impactful it is. So the user can decide what's the best compromise for them between recent data, papers with impact, and papers that are very, very specific to their need. So they explore the right amount of the literature, and they select the document that they want to include into their report. Then we ask the user to specify its aim with the report, and with this aim, we suggest a plan. The AI got the query, the aim, the articles, so it can suggest a plan. Again, the user can validate or improve the results. And then AI writes the summary, and once again, the user can, with or without the help of AI, improve the summary. We consider that when people write a scientific report, a scientific summary, they spend about 80% of their time just giving an overview of the literature, and 20% adding really the special value. Our aim is to reduce this 80% of the time to nearly 0, so that they can spend more time adding their special value and adding really what will make their report special, and that what will make the value of their report. All right, so I've shown you basically how we proceed with to create good reports with using AI based on trustful scientific information. And so using AI, we managed to have to extract the right information, to have data security, and to have a coherent and well-sourced response. Thank you very much for your attention, and I'm here to answer one or two questions. Yes.
Thank you, Sylvain. I was wondering, you mentioned this data sets of 200 million data. Are you accessing through open access, or do you have agreements with publishers, scientific publishers?
So we access through public data sets. So it's open access. So we have basically all the documents, and when it's not open access, we have just title, abstract, authors, and when it's open access, we have everything. And if the user has access, has both access to the document or has access one way or the other, they can add it so that it's included with the platform. We also have indeed feature where you can just select the document, the present document that interests you, and we send you documents in the same space every month or every week, depending on what you want. One last question, maybe? Yes. So we use LLM on shelf. Of course, we don't train from scratch our LLMs, and then really the training we do is at the level of the pipelines. We don't really fine-tune LLM, but rather build pipelines where we have a training set that use LLMs. What we're good at is extracting information, extracting value from research articles. But if that's what you want to do, and if you want to have it in a clear, concise way for marketing people, it's also possible indeed. Okay. Thank you very much.